In this video, I'm going to do two questions that is based on factor theorem. Theorem says that if Px is a polynomial of degree greater than 1, right, and a is any real number, then the first statement is x minus a is a factor. X minus a will be factor if Pa is equal to 0. And we can, to converse of this, we can say that if Pa is equal to 0, then x minus a is a factor. So what we can see here that in this question we are given that using this theorem, we need to show that 2x plus 1 is a factor of this polynomial. So what I'm going to do is, let's say consider this polynomial as px. So over here, I'm considering this polynomial as px. So px is equal to, this is 2x cube plus 3x square minus 11x minus 6. Now, since it is given that since 2x plus 1, it is already given to us 2x plus 1 is a degree, is the 0, is 0 of px, then 0 of this. So what you can do, equate this, in serif and find it 0, which is what? Transposing 1 to the other side, minus 1, and then transposing 2, it is minus 1 by 2. So we can say that p minus half should be 0. Now what you're going to do in the next step, let's replace x with minus half. So that will come as 2 into minus half raised to the power 3 plus 3 times minus half square minus 11 times minus half minus 6. Now you see this is 2 and cube of half is, this is minus half, so it's minus 1 by 8 plus 3 times minus half square is positive 1 by 2, and this is multiplied minus 11 into minus half will give you positive 11 over 2 minus 6. Now, after that, we'll be simplifying it. And for simplification, I'm doing it on the other side. But you can see that here some part is getting reduced. I can reduce this 2 with 8, that is 4 times. So what you'll get, this is minus 1 over 4 plus this is 3 over 4 plus 11 by 2 minus 6. Let's solve this part first. So this is minus 1 plus 3 is 2, right? Minus 1 plus 3 is 2, that is 2 over 5 plus 11 over 2 minus 6. I can reduce as 1 by 2. So you can see it is coming 12 over 2 and minus 6. I can reduce it further. Right, this is by 6 times. So what you are getting here is 6 minus 6, that is equal to 0. And this is how we prove that 2x plus 1 is a factor. 2x plus 1 is a factor, right? This is what we need to prove that 2x plus 1 is a factor of this polynomial. Now let's see how we will do the second part also in the same manner. In the second part, we have to prove without actual division that this is exactly divisible by x square minus 3x plus 2. So what you need to see here that this is this polynomial where we cannot use the factor theorem directly. As you can see, this the divisor has to be a linear, but this is not a linear polynomial. So what we are going to do is to split them into two linear polynomial. Let's say if I write this as gx, and which is x square minus 3x plus 2, clearly it's a quadratic polynomial and can be factorized here by the middle term factorization. I can write 2 as 2 into 1, right, or 1 into 2, and write this as minus x minus 2x, so plus 2. So what I have actually done here, I've written minus 3x, in fact, split the middle term, minus 3x as minus x minus 2x. Now you can check here. We can continue to factorize it. X is common between the first two terms. Minus 2 is common, so dividing by minus 2 will get x minus 1. So we are getting x minus 1, and this is x minus 2. So we got two factors of this. And then what we can do, we will equate them with 0 in order to find the solution. So we are going to equate here with 0. Now equating x minus 1 with 0, I'm getting x is equal to 1, and equating x minus 2 with 0, I'll get x is equal to positive 2. Now we are going to show one by one that in each case we are going to show here that both 1 and 2 is the 0 of this px, that is the polynomial, which is 2x raised to the power 4 minus 5 times x raised to the power 3 plus 2 times x square minus x plus 2. So let's say first if I place x as 1 here, I'm getting 2 times 1 raised to the power 4 minus 5 times 1 raised to the power 3 plus 2 times 1 raised to the power 2 minus 1 plus 2, replacing x with 1. As you know, with positive power, 1 raised to the power any positive power, sorry, even 1 raised to the power, yeah, is 1 only. So 2 into 1 is 2 minus 5, 2 into 1, and minus 1 plus 2. Now check here, 2 plus 2, 4 plus 2, 6. So this is giving us 6, and minus 5 minus 6 minus 1 is minus 6. So we got 0. Now the same way, I'm going to replace x this time, this polynomial. Here I'm going to replace this polynomial with 2 now. So what we'll get if I plug in x as 2. So that is 2 into 2 raised to the power 4 minus 5 times 2 raised to the power 3 plus 2 times 2 raised to the power 2 minus 2 plus 2. Now, what we are getting here, 2 raised to the power 4, that is 16. So we should show that is 2 into 16 minus 5 into 2 raised to the power 3 is 8, and plus 2 into 2 raised to the power 2 is 4. And we can even cancel this minus 1 plus 2. Minus 2 plus 2. So this is giving you 32, and 5 into 8 is 40 plus 8. Now 16 plus 32 plus 8 is what? 40, and this is minus 40, and you know this is equal to 0. So what we have shown here, that since 1 and 2 is the 0 of this polynomial, right? And by factorization, we have shown that here this divisor, the factors, the zeros of the divisor is same as the 0 of the dividend. Therefore, this proves that x plus x square minus 3x plus 2 is a factor of this polynomial.